We're going to do some reviewing on lessons 5.1 through 5.3. If you look at page 106, we have the check your progress. These first problems we might come back to later. Right now we're going to go to number 5. So the directions here, it says substitute to determine which value, if any, is a solution. So they've given us the equation. What we're doing is substituting numbers in to see if they work. When you substitute the numbers in, technically we should put a question mark by the equal sign because we don't know if these are equal or not. So for choice A, if we substitute a 3 in, order of operations, we need to multiply first here. 5 times 3 is 15. 15 plus 8 is 23. On the other side, 10 times 3 is 30. 30 minus 2 is 28. We know 23 is not equal to 28, so we know that choice A does not work. If we try choice B, we're going to substitute a 4 in place of x. So on this one, first on the left side, 5 times 4 is 20. 20 plus 8 is 28. It's up to you as you do these if you want to just go all the way down on one side, finish it out, and then work out the other side, or if you want to work them out simultaneously. So on the right side, 10 times 4 is 40. 40 minus 2 is 38. So that doesn't work. We can continue this for part C. I'm going to rewrite the problem because I can't see it on the screen right now, which is not a bad idea just in general. If you just rewrite the equation, it makes it easier for substituting. Okay, so same idea on this one. Should be 33 and 48. And those are not equal. And that's the end of the line. So this is choice D, none of these. Okay? So on your test, it'll give directions on what to do. They're not, it's going to say, you know, like if none of them work, write none. I tried to use the same directions as your book. I'm not trying to trick you guys. I'm trying to make it easier. So I try and use the same directions your book has. We'll look at number 6 next. So this is a similar type problem. So we have options of substituting 7, 8, and 9. And it's up to you how you want to do these. Nothing says you have to start with a certain option. So, you know, if you wanted to start with the 8, you can do that. One thing, like I mentioned on the last problem, it's not a bad idea just to rewrite the equation and then substitute. So order of operations on this one, we would do in the parentheses first. 8 minus 2 is 6. And then 2 times 6 is 12. 12 is not equal to 14, so that doesn't work. So that didn't work. I guess we'll go back to the 7 while we're here. So if we try that, we've got 7 minus 2, which is 5. 2 times 5 is 10. And 10 is not equal to 14, so that didn't work. Well, hopefully C works, or we've got another one where nothing works. We'll see what happens here. So 9 minus 2 is 7. 2 times 7 is 14, so that works. So choice C would be our answer for this problem. The next set of questions says use the addition or subtraction property of equality to solve each equation, check each solution. On your test, I'm going to probably have different questions grouped together where the directions might just be solve and check your solution. So if we look at number 8, remember what we talked about is trying to do the opposite operations. So on number 8, we're trying to find what m is equal to. We need to get the m by itself. They're adding 17, so the opposite operation, we need to subtract 17. We need to do the same thing on both sides of the equation to keep this balanced. And when you subtract that, you should get 15. So m equals 15. If you have time, you can go back and check your solution by substituting it back into the original equation. And when you add those 15 plus 17, you'll get 32. Then we know we've got the right answer. If we go down to number 13, similar idea, the variable's on the other side of the equation, but the idea is the same. They're adding over with the variable means we need to subtract. We need to do the same thing on both sides of the equal sign, both sides of the equation here. When you subtract, make sure your decimal points are lined up, would be 2.1. And once again, you could substitute that back in the equation to make sure that it works if you have time. Number 15, over with the variable, they're subtracting 15, so it's kind of like they took away part of what our variable is. So if they're subtracting, opposite operation, we need to add 15. That would be like adding 15 and 0/10. Always make sure your decimal points are lined up when you add or subtract decimals. When you add those together, would be 99 and 6/10. We'll look at number 20. Again, the directions on your test, I'm not going to have all this. I'm just going to say solve and check your solution. So on number 20, the 15 and a are right next to each other, means they're multiplying, means we need to divide. And normally this is how we want to show that we're going to divide. We divide by 15. Makes 15 divided by 15 is 1, and 1a is the same as a. And then if we divide 75 by 15, if you work that out, you should get 5. And once again, we can check the answer, and it'll work. On number 21, I'm going to rewrite it because I don't have too much room over here, but variable is being divided by 11, so we need to multiply by 11. And when you multiply that, work it out to the side. If you don't remember this fact, this is 132. We look next at number 27. The directions for this section, they want us to write and solve an equation. So we need to make sure that we do write an equation and also solve it. When you write an equation, it should be something all on one line, and it has to have an equal sign in it. If you're not sure sometimes on these problems what your equation would be, if you want to just work it out and then think about what did you do to work it out, and then go back and try to find what your equation would be. So on 27, the difference of a number and 16.2 is 8.8. Difference means we're going to subtract. If they say the word difference, we're going to keep these in the same order as they're in right now. So this could be like n minus 16.2. If you picked a different letter, they didn't tell us what letter we had to use. The word is usually means equals. So this would be our equation to start out with. So to solve this, then they're subtracting. We need to add 16.2 on both sides. when you add those together, you get 25 and 0/10, which is the same as 25. And once again, we could put that back in the equation and see if it works. For time's sake, I'm not going to go through that process, but look at number 29. We have a product of a number, and 102 is 25 and 5/10. So the word product means multiply. You might have heard me say before MP3, like an MP3 player, multiply product. So we have the product of a number and 102 is, so equals 25 and 5/10. I'll probably give you a little bit nicer numbers than this for most problems on your tests, but you're capable of doing this. It just would take a little bit longer sometimes. So they're multiplying by 102. We need to divide by 102. When we go to do this, when we're dividing this, remember the numerator. We have a numerator, denominator. The numerator goes on the inside. N for numerator on the inside. And we're okay with our decimal here. We just can't have a decimal for the divisor on the outside. So if you try and divide this out, 102 doesn't go into 2. It doesn't go into 25. If you want to put zeros there, you can. We're looking first at 102 into 255, which would go 2 times. You could work that out to the side, would be 204. And then we can add a 0 and bring it down. And this did not look real great for a minute there, but actually 102 goes into 510 5 times evenly. So our answer would be n equals 25 hundredths. A lot of times they'll put a 0 and then a decimal point. If you just put 0.25, it's a little bit harder to see the decimal point sometimes. That's why they put the 0 in front, I think. Number 30, select the equation that can be used to solve each problem. Natalie buys 90 eggs to make cupcakes for the bake sale. There are 18 eggs in each carton. How many cartons C does she buy? One thing, even though it doesn't specifically say we have to solve this problem, if you want to help make sure that you've selected the right choice, you could work it out just to make sure that it makes sense. Like if we think about this, if we bought 90 eggs and there's 18 eggs in each carton, it should be that our answer is that she bought less than 90 cartons. Because, you know, even if we just put 1 egg in each carton, 1 egg in each carton would be 90 cartons. We have 18 eggs in each carton, so we should have way less than 90 cartons when we work this out. So if we look at these different options, actually the one that's going to work, pause it if you haven't had a chance to look at it yet, would be choice A. This might not have been the way that you would have worked this out, but if you think about this, to solve this problem, they're multiplying, you would divide by 18. So 90 divided by 18, hopefully that makes sense to you. There's 90 eggs, we're dividing it into cartons of 18 each. And then that would be how we would figure out our answer, which looks like it would end up being 5 cartons. Again, they didn't ask us to solve it, but you know, just to understand and make sure your answer comes out to be less than 90. Like if you chose B, on B you'd have to multiply by 18. 90 times 18, that would be a lot of cartons. Most of the cartons wouldn't even have any eggs in them, so that probably would not be the one that would make sense. Look at number 33. They want us to write and solve an equation that represents the problem. Gavin ran 8.2 miles on Monday. This is 4.3 miles less than he ran on Sunday. How many miles did Gavin run on Sunday? So there's different ways to do this. Whatever method you choose, we need to notice that basically they're telling us that he ran more on Sunday than on Monday. So the most he ran was on Sunday. And that we don't know. We don't know the distance he ran on Sunday. We do know on Monday he ran 8.2 miles, which we know is less than the amount he ran on Sunday, because it says this is 4.3 miles less than he ran on Sunday. So we need 4.3 more miles in order to equal the amount he ran on Sunday. Okay, it did say to write and solve an equation, so one way we could do this equation, we might say let M represent miles ran on Sunday. That's defining our variable. And then, so our equation, how we have the bar diagram set up, it looks like the miles would be equal to 8.2 plus 4.3. And so if you add those two together, it would be 12.5 miles. Another way you could look at this is if you take the information they gave you. They said first 8.2 miles on Monday. It says this is, so another way you could write an equation, you could say 8.2 equals 4.3 miles less than he ran on Sunday. So what he ran on Sunday, we don't know. We're using M. 4.3 miles less than that, so it would be M minus 4.3. And then if you set up the equation that way, they're subtracting, so you need to add 4.3 to both sides. And then when you work that out, that would give you the same answer. Okay, just understand when you're doing these problems that part of your answer is your equation. So probably would be good, like over here, if you actually rewrote the equation when you're working it out so that it's easy to see. Instead of you start crossing things out, it's hard to see what all you've done there. Number 36, Jacob has 108 inches of rope. He uses a piece to tie up a bundle of newspapers. He has 65 inches of rope left. How many inches of rope did he use? Okay, so one way of doing this, we could think about with the bar diagram. The whole piece of rope we had to start with is 108 inches. He used a piece of rope, so maybe P for piece of rope. And then he has 65 inches left. So maybe that piece isn't quite as big as I'm showing it here, but 65 inches left. Okay, so one way, if you look at this, the piece of rope plus the 65 inches left, those two things added together, those two pieces added together, equal the 108 inches that we started with. So this would be one way you could work this out. They're adding, so you could subtract 65. And when you subtract that, you'll have to borrow here. Sorry, 8 minus 5 is 3, but then borrow. 10 minus 6 is 4. So that piece would be 43 inches. And once again, once you get that answer, you can just verify that that makes sense. We had a 43-inch piece, 65 inches left. Those two added together equal 108 inches. We're going to look at a few problems on page 118, the chapter 5 review. Some of these questions don't really match with what we're doing right now because we haven't done all of the sections in chapter 5 yet. I'm going to start with 26, another question where we have to write an equation. Notice the directions. It says you do not need to solve for the variable. Now, even if those were the directions on the test, if I had time after I finished the test, if I had time, I would actually go back and work the problem out just to make sure my answer is reasonable, make sure it makes sense. So 3 tickets to the amusement park cost $42. How much does each ticket cost? Okay, and once again, we have to write an equation. It says or inequality. We'll talk about those later. Okay, so the 3 tickets cost $42. $42 is our total. And we have 3 tickets. Imagine these are all the same size. I know they're not exactly the same with how I've drawn them, but okay, so basically we have 3 tickets. So if we could let T represent the cost of a ticket, or a ticket to the amusement park if you want to be more specific. So we have 3 tickets, so 3 times the cost of 1 ticket is equal to $42 total. If you had T times 3 equals 42, that's fine. Technically, they didn't say what kind of equation we had to write, so as long as you come up with something that works. So you could think, well, it's $42, I'm going to divide that by 3. That's fine. Just make sure you write an equation. Sorry, 42 divided by 3. Okay, equals T. That could be your equation also. If you had time, you could work these out. And if you work that out, I'm going to work it out up here. 42 divided by 3 is 14. So that tells me each ticket costs $14. That seems reasonable. And once again, if that was my equation, I could substitute it back in here and make sure that that works. So 14 times 3 is 42. And we know we've got the right answer. Number 28, Melanie buys a bag of popcorn and receives $1.26 in change. She paid with a $5 bill. How much does a bag of popcorn cost? Okay, so on this problem, if you were doing a bar diagram, think about the $5 is more than what the popcorn costs because it says she paid with a $5 bill and she got some change back. So we have the cost of the popcorn. So if you want to do C for cost or P for popcorn, she got $1.26 in change. So the cost plus $1.26 would be equal to $5. This would be one way you could do this. They're adding, so we need to subtract $1.26. would be $3.74. Okay, and if you looked at that and you just said, well, I know I need to do $5 minus $1.26, that's fine. Just make sure you write it on one line, and make sure you write it as an equation, and then you're going to do the same thing as we just did here basically to get that answer. There are other problems here in your book that we can look at. I'm just going to kind of quickly go through these, so if you want to pause it before I work it out, might be a good idea. This, we're just substituting numbers in and seeing what works. So if you want to pause the video, I'm going to give away what the answer is here. Okay, if you put a 5 in place of the x, that one actually works. So x equals 5. And there's only one, for the equations we're doing right now, there's only one possible value at the most that can work. So if you find something that works, the others should not work. Once again, if you had time, you could try them just to make sure that you worked it out correctly. Number 12, we didn't do one quite like this, so probably don't expect to see this on your test, but this problem, what you would want to do actually is go ahead and subtract these first. 26.1 minus 13.4 is 12.7. And then once you've done that, now you can say over with the variable they're adding 8 means I need to subtract 8. Would be 4.7. And you can always substitute that back in and make sure that that works. Number 14, they're multiplying, so you would need to divide. And actually, when you divide by 100th, we talked about earlier in the year, that's going to end up moving your decimal over 2 spots to the right. So this would be 340. If you were working it out by hand, if you forgot that factor, if the numbers were different, just remember your numerator goes on the inside, and you can't have a decimal on the outside as a divisor. You end up with 340 divided by 1, which would be 340. On these questions, they want us to translate them into either a word sentence or a number sentence. So 24 you would need to translate into words. You could just say like a number divided by 9 equals 3.2 or equals 3 2/10 would be fine. 25 they want us to translate it into an equation. So the product means multiply. The product of 2 and a number, so like 2n, is equal to 6. It didn't ask us to solve, so that's all we have to do. So this gives you an idea of how to do some of the problems in lessons 5.1 through 5.4. Once again, you have other options for reviewing IXL or something like that that you can do to help you review for the test some more. Have a good day.